This lesson is lesson 7.5, scale and scale factor. So scale is when you have a map or a model of something that is smaller than the actual object, or sometimes bigger than the actual object, like if you're looking through a microscope. But normally it's something that is a model or a map that's smaller than the actual thing you're talking about. And when you have that scale drawing is a proportional two-dimensional drawing of an object, and that scale model is a proportional three-dimensional model of that object. The key word here is proportional. So because it's proportional, we're going to use the cross product method to solve these problems. So you'll be cross multiplying and dividing to get the variable alone. So scale is the measurements in the scale drawing and models are proportional to the measurements of the actual object. The scale gives you the ratio that compares the measurements of the drawing or model with the actual measurements. It's how you're able to read a map and determine what the actual distance is, even though you measure inches or centimeters on the map. So when you're given a scale of 1 inch to 10 miles, you would write that as a ratio of 1 inch over 10 miles. So when you're solving a problem like this, you're going to be given a situation, and the first thing you're going to do is create a proportion, and the first ratio is your scale, and the second is the measurement that you have and the variable. Okay, you're going to line it up with the labels and the measurements within that scale. Then you're going to cross multiply and you're going to divide to get the variable alone. Those are your steps. Okay, so if you're given the scale here of 1 centimeter to 1 centimeter equals 50 miles, that becomes your first ratio. And then you're going to be given another measurement, that 3.5, and then that's over your variable. Okay, so 3.5 is given, and you're going to line that up with the scale. So 3.5 is centimeters, and centimeters is on top, so it's got to go on top, and then the variable goes in the bottom. So if you look at this example, and if I line it up as 1 over 50, 1 centimeter over 50 miles, and is 3.5 over x, you're going to cross multiply and take 50 times 3.5 equals 1 times x. 50 times 3.5 is 175 equals 1 times x, and 1 times x is x. You could divide both sides by 1, but you just get the same answer because of the identity property of multiplication. So it's just 1x equals then x, and then you bring down your answer of 175 miles. Make sure you label them. Okay? Okay. So if you look at this next example, when you're finding a distance in a model, so they give you the scale of 1 inch is 500 kilometers, and they tell you that the measurement that you have is 2,300 kilometers thick. So you're going to line up your proportion of 1 inch over 500 kilometers equals x over 2,300 kilometers. The kilometers, because we have kilometers as our other measurement, that goes on the bottom, and you line up kilometers with kilometers, and then our empty space, the inches, becomes your variable. And then you're going to cross multiply. So you would take 1 times 2,300 equals 500x. 1 times 2,300 is 2,300 equals 500x. You then divide both sides by 500, and you get an answer of 4.6 inches. Okay, I'd like you to pause your computer and do number 2 on your own using this same scale. Okay, so 1 over 500, 1 inch over 500 kilometers equals, and we're given 2,900 kilometers thick. So that goes on the bottom, and x goes on top. So you cross multiply, 2,900 times 1 equals 500 times x. 2,900 times 1 is 2,900 equals 500x. Divide both sides by 500, get the variable alone. 5.8 inches is our answer. Okay, then there is scale factor. Scale factor is when scale is written with the same unit of measure. So you're going to be converting units of measure. My suggestion to you is going to be to convert to the smaller measure. You want to make them the same unit, and I suggest that you always do the smaller. So if you're given feet and inches, make both of them inches. If you're given centimeters and millimeters, make them both millimeters. If you're given centimeters and meters, make them both centimeters. Whatever is your smallest unit of measure is the one that you should convert. So in this example, if I have a scale of 1 inch equals 10 feet, what you're going to do is make them both inches. So the 1 inch stays the same. And in order to make that 10 feet inches, you need to multiply it by 12. So that becomes 120. So my scale factor then is 1 over 120. And because it's the same measure, you don't need to write a label. It just becomes 1 over 120. That would be your scale factor. Okay, so I would like you to do number 3. Pause your computer and change that scale into the scale factor, meaning the same unit of measure. Pause your computer and do that, and then come back. Okay, so if my scale is 1 millimeter over or equals 20 centimeters, I need to make that into millimeters. So 1 millimeter, there are, 10 centimeters in a, or 10 millimeters in a centimeter. So you have to take 20 times 10. So you end up with 1 millimeter over 200 millimeters, or 1 over 200. That would be your scale factor. You do not write labels with scale factor. Now, if you're given a scale factor and solving for a given scale factor, you have to then remember that you have to put it back in the normal unit of measure, because I'm not going to, if I'm talking about, for example, if I'm going feet to inches, inches to feet, and now I have it all in inches, if I'm measuring the distance around my house, I don't want to do that in inches. I want to do that in feet. So when you're done, you use your scale factor in that proportion, but when you're done, you have to convert it back to feet by dividing by 12. Or in this case, if it was centimeters dividing by 10, you would do the opposite of what you did to make the scale factor. Okay? Okay. So I then would like you to do number 3, and then number 7, and then number 13. Okay? 3, 7, and 13 for tomorrow.